Okay, Assalamualaikum. My name is Muhammad Nabil bin Nazri. My metric number is DE220195. So now I will show the simulation for Lab 1 Activity 2. So for part A, for step 1, it told us to store number 65 in address location for 22. So when we open the CPU simulator, the instruction for the first step is stb hashtag 6520. So basically it tells us to store the value 65 into the address 20. So when we open the show program data memory, so we count from here 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So 20 will show us the value is 41. So it show 41 because the value is in hexa, not in decimal. So if we pull out our calculator and then we put the value 65 in decimal, and then we see the value for hexa is 41, which is the value in the address of 20. So that's for step 1. And then for step 2, it tells us to move the decimal number 22 into register in RO1. So this is the instruction for the second step. If we MOV hashtag 22 RO1. So this is basically we just move the value 32 into RO1. And then for step 3, it tells us to create an instruction to store decimal 51 in memory location of address which is currently stored in register RO1. So this is an indirect addressing. So this is the instruction for the step 3. So based on the instruction, it's basically show us that the decimal value 51 has the same address as 22, which is at RO1. So that's for step 1 to 3. And then if we want to observe the data memory location, we can just open the show data folder memory, and then it will show us the value at the exact address that we put for our simulation. So that's for part A. Thank you. Okay, now we move on to part B for our lab. So for part B, which is step 5, so it shows us the example code. So to break down the code, first we open this simulation, and then this is move 0 R01, which is it will set our RO1 initial value into 1, and then L0 is our label, and then this is R1 R01. It will add the value 1 into R01, and then this is CMP, which is comparison. So for comparison, we compare our value at RO1, which is 5. Then this is jump and end at level 0. So this program is intended to make sure that the value for RO1 will become 5. So until the value for RO1 is 5, the program will jump at level 0 until the value become 5, and that will halt the entire program. This is basically all this program about. So and then we move on to our step 8. which told us to modify our example code to make sure that the program loop repeated as long as the value of R01 is less than or equal to 3. So for this instruction, we can just change our okay. So for this so to modify this, what we need to do is we can just modify our comparison. So can edit it into 4. So the program will loop until the value at R01 equal to 4. So then we can put our subroutine. So before we put our subroutine, we first need to put our MSF, which is mark step frame. We need to put it before our comparison. So we put MSF followed by CLL label 1. And then for our output, if we want to edit our output, we can just change it here, put our string, and we can put our anything that we want to be our output. So for example, BEJ40401. So we just update this, then we close. So when we run our program, and then we wait for the program to run. Okay, so after it run, our output, sorry, okay. And then we run. Okay, so for the output we will get 4 of our text that we edit. So that's all for part B. Thank you. Okay, so this is for the last part of our lab. So we are given this example code too. So this example code we can break down. So first it has push 8, which is it will push our value 8 onto the top of the stack. So and then this is CAL level 2. So we push it to level 2. So we pop at RO2, and then we move value 0 to R1. So and then at level 0, it has at 1 at R01, at R01. So after that we have MSF and CAL at level 1. And then this is comparison for RO2 and RO1. So this is jump in at level 0, and then this is return, this is level 1, and this is our output, and then this is return. So this program, so if we run our program, it basically will push our 8 into RO0, and then we'll add value 1 into RO1. So until the value for RO1 equal to RO2, the program will looping until the value for RO1 and RO2 is equal, and then the program will basically halt. So just wait until our value for RO1 become 8. So after our RO1 value become 8, you have the same value, and then the entire program will halt. So this is all for this part, and that's all for this lab. Thank you.